Again, welcome to Inferential Statistics in Decision Making. These lectures cover the normal distributions, finding values. Our main objective is to learn how to find a z-score given the area under a normal curve. Also transform a z-score to an x value. And also we're going to learn how to find a specific data value of a normal distribution given the probabilities. So in our previous section, which is section 5.2, we were given a normally distributed random variable x, and we were asked to find the probability. So normally the mean and also the standard deviation of the population will be given. So if we know the value of x, then we can find the z value. Then if we get a z value, we can use the standard normal table to find the probability or the area. Now this time we are going to do opposite. The probability will be given and we can find the z value. And if we know the z value from the probability using the table, we can be able to find the x value, which will be our random variable. So again, section 5.2, the random variable x is given, and they say we should find the probability. Let's say probability that x is greater than 30. So that means s value is 30. So we can find the z, then we find the probability. Now this time, the probability will be given, and we need to find the z, then we can find the x. Again, in the normal distribution, always the mean and the standard deviation of the data set will be given. So let's see an example here. This example says we should find a z-score given an area. An area will be the probability. So find a z-score that corresponds to a cumulative area of 0.3632. Now to do this, I don't need the mean, we don't need the standard deviation. We just use the standard normal table in our textbook. So we came up with a sketch again. This time we know the area. We are looking for the z value. So we can go to our table. This is a section of the standard normal table, the z-score. So 0.3632 is given. In our previous section 5.2, we find a z value, then we look for the corresponding probability or the area. Now this time we are going to look the area, then we can find the z value. So 0.3632, we can see the value right here. So which means it's negative 0.3 and 0.05. So it will be negative 0.35. So here we say the value at the beginning of the corresponding row and at the top of the column, giving the z-score. We give us the z. Now, sometimes we may have in this case, the probability value is exactly the same. Let's say, for example, if it was, let's say 0.3640. Now, if it's 0.3640, I know the next value is 0.3669, and to the left is 0.3594. So if it's 0.3640, I will still use the value here because you will use the value that is close to whatever value you get. So here we get the exact value 0.3632. So our z-score will be negative 0.35. So negative 0.3 and the top 0.05. So that the z-score is negative 0.35. Now let's see the next question. Find the z-score that has 10.75% of the distribution area to its right. Now remember, anytime we read the value from the table is from the left. This time to the right means greater. So we know, first thing we need to change this to a decimal value. So 10.75 is the same as 0.1075. So we came up with the shape of the normal distributions. And as we said, we change the probability value to 0.1075. Now the question says to its right. So that's why we shaded this area. So the probability of this area is given to us. because they say 10.75% of the distribution's area to its right. Now we need to find a z-score. So this is our z value here. This time we have to be careful. We can now, previous question is from the left. So we went straight to the table and we use the probability value. Here to the right, we cannot use this value. So first thing we need to do, we subtract 1 minus 0.1075, and that gives us 0.8925. The reason why, and we've went through this in section 5.2, the reason why, again, because when you read the values in the standard normal table, we assume from the left to right, not from right to left. So since our z-score starts from left and to the right side of shading area, the value we get from the table will be from the left to the z-score. So now 0.8925 we are going to use to get our z value. Now here we say because the area to the right is 0.1075, the cumulative area is 0.8925. Now we can use our table and we look for 0.8925. Again, here we have exact value. If we don't have the exact value, we look for a value that is close to the value. So the answer will be 1.2, here 0.04. So the answer will be 1.24. So the z value is, or the z-score is 1.24. Again, here we have to be careful. Let's go back one more time. Since the z-score value, the question said 0.1075 of the distribution area to its right. So we have to subtract the probability to the right, the value from 1, and that will give us the table value reading from left to the z-score. Then we use that corresponding value. Now, when we look at our previous question, here they said locate, and let's go through this, that find a z-score that corresponds to a cumulative area of 0.3632. And they didn't tell us to the right. So this means we use the 0.362 as that value. But the next question said to the right. So we have to subtract that from 1, and that will give us from the left to the z. Then we use that probability 0.8925 to find the z value or the z-score, which will be 1.24 based on the table. Next, they say we should find a z-score that corresponds to P5. So here we are looking for z-score given a percentile. Now, the z-score that corresponds to P5 is the same z-score that corresponds to an area of 0.05. So that's what we mean by P5. So the area of 0.05 will give us the P5. Here we can see that we know the area is from left to the z-score. So the area closest to 0.05 in the table are 0.0495, which gives us negative 1.65. Now, since this value is from left, when P5 is area 0.05 from left shaded to the z, we are going to use the probability value here to find the z-score. And looking at the table, the closest value is 0.0495, which is negative 1.65. And also we have another value, 0.0505, which is negative 1.64. Now here we say because 0.05 is halfway between the two areas in the table, we can use the z-score that is halfway between negative 1.64 and also negative 1.65, which will give us negative 1.645. Okay, so next we are going to learn how to transform a z-score to an x-score. So our previous question, we were given the probability and we were able to find a z. score using the table, standard normal table. Now we're going to learn how to transform a z-score, which is given, to an s-value. So here we say to transform a standard z-score to a data value x in a given population, we use the formula as following. This formula is the same as z equal to x minus mu over standard deviation. So when we transform the formula, we get s equal to mu plus z times standard deviation. So let's try one example here. Here they said the speeds of a vehicles along a stretch of highway are normally distributed with a mean of 67 miles per hour, and also the standard deviation is 4 miles per hour. Find the speed x corresponding to the z-score of 1.96, negative 2.33, and 0. So here you can see we are looking for the x, which is the speed, but the z value is given. So if z value is given, it's easy. We can just solve it using, again, the form transforming the z-score formula. S will give us mu plus z standard deviation. So we say use the formula x equal to mu plus z, the standard deviation. Mu, which is the mean, is given to us. Standard deviation is given, the z is given. So when z is 1.96, the x value is 67, which is the mean, plus 1.96 times the standard deviation, which is 4. So that gives us the s value to be 74.84. Now, when the z value is negative 2.33, we substitute the z value for negative 2.33. And that gives us 57.68 miles per hour. Now, when the z value is 0, we substitute 0. And that means the s value will give us 67 miles per hour. So here they say we should notice that 74.84 miles per hour is above the mean, but 57.68 miles per hour is below the mean, and 67 miles per hour is equal to the mean, which means if the z value is the same as, again, if the z value is 0, then the x value will be the same as the mean. And here we can see that when the z value decreases, the x value also decreases. Okay, let's see one more example. Here they say we should find a specific data value. The scores for a civil servant's exam are normally distributed with a mean of 75 and a standard deviation of 6.5. To be eligible for civil servant's employment, you must score in a top 5%. What is the lowest score you can earn and still be eligible for employment? So the lowest score in this case will be our random variable x. Luckily, the p is given to us. So here, this is our p, 5%. It's top, so it will be to the right. Since you must score in top 5%, it have to be greater than 5%. Now, we don't know the z value. If we can get the z value, then we can easily find the x value. But since we know the p value, we can use the table to find the z value. Then we can use the transform of the z value formula to find the x value. So let's go through the step. Here we say an exam score in the top 5% is any score above 95 percentile. So find the z-score that corresponds to a cumulative area of 0.95. So from the standard normal table, the areas closest to 0.95 are 0.9. Again, if you use the table, this is what we get, 0.9495. And the next value close to 0.95 is 0.9505. So we can find the average of the two, or the halfway between the two, which gives us 0.95. And then we can find the z-score for it. So you can see that here we didn't use the 5%. Why? It's the same as the previous example we did, and also the previous lectures. Since we can see the shaded area is Z to the right. The table always gives us a value from left to the point of the Z. So we need to find that shaded area probability, which become 0.95 because 5% is 0.05. So 1 minus 0.05 will give us 0.95. So we use the 0.95 to the table. So the 0.95 in the table gave us 1.645. Okay, now we know the Z-score. We can be able to find our X value, which is the main thing we are looking for. So here we use the transform formula, X equal to mean plus Z times standard deviation. So we know the mean is given to us to be 75. We just find the Z value of 95% or 0.95, and that gives us 1.645. Standard deviation is given to us 6.5. So if we do this arithmetic operation, we are going to get approximately 85.69. So here we say the lowest score you can earn and you can still be eligible for employment is roughly 86, because the Z started 1.645 correspond to 85.69 to the right. So anything to the left from 1.645 is not eligible. Now, so in this session, again, we stay covering the normal distributions. We learn how to find the Z-score, given the area under the normal curve, using the standard normal table. We also learn how to transform the Z-score to an S value. In this case, the standard deviation will be given, the mean will be given. Then if Z-score is given, we can find the X using the formula Z equal to X minus mu over standard deviation. We look for X, which will be S equal to Z plot N. And then also we learn how to find a specific data value of a normal distribution when the probability is given. So again, see you in the next lectures, and thank you for your time.